So this is a ducted air conditioner inside a typical house with a ceiling cavity with the external unit, refrigeration pipes that go up to an internal unit which sits in the ceiling cavity, and ducting runs typically between rooms. Let's say you're trying to heat your home, switch the system on. The external unit will be cold and the internal unit will have hot coils. What the system does is it pulls in cooler air by this return side. It heats that air up and it pushes the same air back into the room. And it continues this cycle, heating the air in the room up until it's at temperature. There's a little temperature gauge in here which picks up what the room temperature is. And once it's at temperature, it'll stop for a bit until the temperature drops, and then it will continue on the cycle. There's no fresh air introduced. It's simply recirculating the air through the home, controlling the temperature. It has a very minor effect on humidity or dampness. It has a major effect on temperature. So if temperature is your primary concern, a ducted air conditioner will work really well. Not so much for dampness, mold, mildew, humidity problems. Same thing applies for a high wall heat pump. Essentially, it's doing exactly the same thing. Let's say you're trying to heat the air inside. Internal will be hot, external will be cold. Essentially, it's pulling in air from the room into the top of it. Cooler air goes into the top, gets heated up and pushed back into the room. Same thing again, it continues to recirculate the air within the room until the air is at temperature, at which point it turns off the heating, keeps circulating until the temperature drops, turns back on and controls temperature to a certain set point. Again, doesn't introduce any fresh air, doesn't force out any stale air. The main purpose is just to control temperature within the home. Now that's opposed to a ventilation system. Now, what a ventilation system does is it pulls in fresh air from the outside. Because the sun is shining on the roof all day, you get lots of solar rays on the roof. It heats this roof space up. So as the air travels through the roof space, it heats up and it goes in to the intake, which is usually located at the apex, the hottest point. What it does from there is that hot air gets pulled through by the fan and it gets pushed into the home at positive pressure. So imagine your home's like a big balloon. It's being pushed into, all of the air is being forced into that home. So your home is at positive pressure. This is positive pressure system. And that air now needs somewhere to escape. So the stale and moist air, which is in your home, starts to escape out different pathways. If you've got timber joinery, it will start to escape out the cracks in the timber joinery, which is why it's excellent in older homes, not so good in newer, well-sealed homes. And it'll also make its way just passively out extraction pathways. So let's say this is a bathroom extractor. That air that's being introduced will passively make its way out. Same thing with range hoods. If this is a range hood which is sitting on the wall, that air is going to make its way passively out through there and to the exterior. So a minor effect on heating, because it is going to heat the external air coming in and push it into your home. Particularly in winter, it's a good thing. It'll increase your temperature by a couple of degrees, but it's not its primary purpose. It doesn't control temperature. What it does is it introduces fresh air into the home, forcing out stale and moist air out of the home. So it has a massive effect on mold, mildew, dampness because it's forcing moist air out. Has a minor effect on heating and temperature by heating up the intake air. Lastly, air conditioners can pull moisture out of the air. They can only do it on cooling mode. So let's say this is cold coils in here and this is hot coils and the air is coming out this way. If it pulls in, let's say hot and moist air from the room, that hot moist air will meet those cold coils, and just like hot air meets a cold window in the mornings, the condensation will form on these internal fins. That condensation does drip to a drip tray, and then that drip tray is connected to a drain, which will take those droplets outside. So it does, that's on dehumidify mode and on cooling mode. Essentially those two are the same thing. So it is going to pull a bit of moisture out of the air. However, you're using a lot of energy to try and pull that moisture out, and it only works on cooling mode, and dampness issues tend to be exacerbated in the colder winter months. And obviously in those months, you don't want cold air being pushed into your home while you're trying to keep the house warm. So they can have a dehumidification effect. However, it's just not the primary purpose of air conditioners, and it's very energy intensive, especially when compared to a classic ventilation system, which is just a fan running instead of a heat transfer or energy transfer process.